All right. So in this section, we're going to talk about the law of sines and everything. So the law of sines is a formula that we can use when we don't necessarily have a right triangle. Everything we've talked to up to this point, we've talked about right triangle trigonometry. Well, now in this section, we start talking about triangles where they may or may not be right triangles. If they are not right triangles, we can use the law of sines. If they happen to be law of sines or right triangles, we can either use the law of sines or previous techniques. It all just depends on what we're given. So what we're normally talking about is oblique triangles. So an oblique triangle is a triangle that does not contain a right angle. A lot of the relationships that we have been studying do not apply in oblique triangles. For example, the Pythagorean theorem, which is one of the biggest pieces inside of trig, will not work if our triangle is not a right triangle. So for example, here's two cases right here of oblique triangles. Notice that in all these cases, our angles here, none of them are 90. In this case, they're all going to be very close. In this case over here, we have this big obtuse angle, which means it's going to be a lot larger than angles B and angle C in this case. So we just have different things to consider whenever we're looking at triangles that are not right triangles. We cannot have acute triangles because it won't add up to 180. So the law of sines can be used to solve a triangle in which one side and two angles are known. So in other words, side angle angle or angle side angle. It all just depends. Side angle angle means that it's just a side and then any two angles. Angle side angle means that it's an angle, a side, and an angle that are all touching each other there. So if angles A, B, and C are the measures of the angles of a triangle, and little a, little b, and little c are the lengths of the sides opposite these angles, then the law of sines states that a, side A divided by sine of angle A is equal to side B divided by the sine of angle B, which is also equal to side C divided by the sine of angle C. We can equate any of these three. So in other words, we could do the first two. We could then do the second two. We could then do the first and the third. It doesn't matter which one we do. We can do any three of these ratios and still solve for whatever we need. It's all dependent on what we're given in the problem will depend on which one we need. We don't have to do all three. We could. Makes it a little bit harder to do sometimes, but it could still be done. So let's see what this looks like in action here. So we're told solve the triangle. Round our side lengths to the nearest tenth and angles to the nearest degree. So in this case, we have angle side angle because we know angle A, side C, and angle B. So what do we know here as an easy thing? So by looking at this, how can we solve for something right here? Well, we can easily solve for this angle because we need another angle or another side real easily here. So we take our 48 plus 42 plus angle C needs to equal 180. So 90 plus C equals 180. So C equals 90 as my answer here. So since I now know that this happens to be a right triangle, because this is 90 degrees, we could use previous trigonometry to solve this, but we don't want to do that in this case. We want to actually use the law of sines here. So the first thing that we're going to do is we're going to do this right here. We're going to do side A over sine of 42 is equal to 12 over sine of 90. And we know that the sine of 90 is 1. So really we have A over sine 42. So A over sine 42 is equal to 12. So then therefore A equals 12 times sine of 42. We type that in our calculator to find that A is equal to 8.03. So since we now know this, we still have one left to do. So we use the law of sines again. So when we do that, 8.03 equals sine of 42 equals B over sine 48. Therefore, when we cross multiply, we get 8.03 times sine of 48 is equal to B times sine of 42. So B is equal to 8.03 sine 48 divided by sine of 42, which gives us that side B is approximately 8.92. Now, if we really wanted to check this, we could check this using the Pythagorean theorem since we know it's a 90-degree triangle. So if we did 8.92 all squared plus 8.03 all squared, we need to get 12 squared. So this needs to equal 144. If we do that by pulling up our calculator, so when we pull up the calculator, we get 8.92 squared. So 79.5664 plus our 8.03 all squared, which is 64.4809. If we add those together, we get 130, 140, about 144, give or take, maybe a little bit over and everything. That's just due to some rounding errors and everything. If we round it to the nearest thing, I think we get 145, actually closer to 145, but it doesn't matter. It's approximately 144. So it's pretty close in that sense. The next example we have here. So we're told solve the triangle again. This time we're guaranteed that one of them is not 90 because of the way that it looks here. 42 and 96. So if we find angle B real quick, so that's 180 minus 96 minus 42 is equal to angle B. So that's 90, that's 84. So we should get that that last side is, thought I had it down there. Is actually equal to 42. So in this case right here, this is a special case right here, as we'll see down here in this answer in just a second. So if we work this out by hand, I know the answer is down there, but let's work it out by hand. So if I did 12 divided by sine of 96 is equal to A over sine 42. So 12 sine 42 equals A times the sine of 96. So A equals 12 sine 42 divided by sine 96. So when we do that, we get that A is approximately 8.07. Now, by symmetry here, since we have two angles, angle A and angle B are both 42, by all methods, B is automatically 8.07. So if we notice that, we can do that. If not, if we notice right here, if we work it out, B over sine 42 is equal to 12 over sine 96. We still get to the same answer no matter what, because we're using the same exact numbers. So it doesn't matter whether or not we're actually working it all out, or if we notice that if any two of our angles are the same, the sides will also be the same opposite of those. So the ambiguous case. If you pull up the slides, you'll be able to click on this explanation here. It's basically a way of showing us different cases here. And I'm going to try to zoom in the best I can here. So we want to consider a triangle in which you are given side A, side B, and angle A. And we know that in this case, H is going to equal to B sine of A. So a necessary condition. So if angle A is acute, a necessary condition is that side A must be less than side H. If we have this, there are no possible triangles. There's no way that we can swing this piece right here and get down here. Not possible. Now, in our second case, if angle A is acute and side A is equal to side H, then there's only one possible triangle. If angle A is acute and side A is greater than or equal to side B, then there's only going to be one possible triangle. If angle A is acute and A is greater than H but less than B, there's going to be two possible triangles. Because if you notice, angle side A is less than side B. So if this side is less than this side, so less than that, we're going to have a piece where we could have one here, and then we could also have one inside of here. We could create two different triangles. I believe we'll see a case like that in just a second. If angle A is obtuse and side A is less than or equal to side B, there are no possible triangles. If angle A is obtuse, A must be greater than B, then there's one possible triangle. And this is the ambiguous case where we know that this is side-side angle is what SSA stands for. So how does that relate back to our next example then? So this is what we know here. I'm going to go ahead and put it all right here on the screen. It says, determine how many triangles and solve each one if there's more than one. Round our side lengths to the nearest tenth and our angles to the nearest degree. So we're given A is equal to 20. So we're given this, this, and this. So in this case, angle A is acute. So in that case, this is angle A, this is angle B, and this is angle C. So we're told that angle A is 40 degrees, side B is 15, and side A is 20. So since A is acute, if we come back and look at our triangle or our cases up here. So we are in these cases. We're also told that side A is greater than side B. So A is greater than or equal to B. That's the only one that uses a condition on B. So therefore, there is one possible triangle. So we come back here. We know enough of our conditions here that we can find angle B first. So 20 over sine 40 is equal to 15 over sine B. That means 20 sine B is equal to 15 sine 40. So angle B is equal to inverse sine of 15 sine 40 over 20. Keep in mind, all of our normal inverse sine rules still apply on that. We have to make sure that we're in the right domain, the right quadrants and everything. So we got that angle B is equal to 29 degrees. We can now find angle C. So angle C is equal to 180 minus 40 minus 29, which is equal to 111. So the last thing we need to find is we need to find little c. So 20 over sine 40 is equal to angle or side C over sine of 111. So C sine 40 equals 20 sine 111. So C is equal to 20 sine 111 over sine 40, which is also equal to 29. Remember, this was 29 degrees. This is a length of 29. So there is a big difference in those two. So again, we look at our stuff. So we have an acute angle. We have that A is less than B. So what are our cases that we have to check up here if A is less than B? So if A is less than B, we need to check our value of H. And that's also going to kind of tell us whether we're in this case, or this case. So we need to do H, which is equal to B sine A. So B sine A gives us 40 times sine of 30, which is 20. So in this case, A is less than B and A is less than H. So since A is acute and A is less than H, we have no triangle that can be formed from this condition right here. So always pay attention to what you're given. Don't try and work a triangle if there's not even one possible. So here's our nice case where we have two triangles. So A is acute, A is less than B. So we know A is less than B. So we find H. In all cases, I would probably find H. Go ahead and find H and see what it tells us. It may help narrow some choices down. So 18 times sine of 60 is 15.59. Be careful with this. That H is a length. So we actually round to the nearest tenth, not the nearest whole number. Because if you make that mistake here, you're going to show that A is equal to H, which puts us in a whole different case. So really, this should be 15.6 by our rules here. So we have two triangles that we have to consider here. So in the first triangle, A1, B1, and C1. So we know that side A is 16, side B is 18. We know angle A1 is 60. So we would have 16 over sine 60 is equal to 18 over sine of B to find this angle. So that means that B1 is equal to inverse sine of 18 sine 60 over 16, which is 77 degrees. To find C1, we literally do 180 minus 60 minus 77 to get 43 degrees. To find little c1, so we now know this is 43. To find little c1, we need 16 over sine 60 equals c1 over sine of 43. So C1 is equal to 16 sine 43 over sine 60, which is approximately 12.6. So that's how we got to our first triangle. Now, to get to my second triangle, we need A2, B2, and C2. So my A doesn't change. My side A doesn't change. My side B does not change. To find one of my angles, what we're going to do to find B2, we're going to take 180 minus B1 every time. So 180 minus 77 gives me 103. So that means that this up here is 103 degrees. So C2 is 180 minus 103 minus 60. That gives me C2 at 17 degrees. So once we find our first triangle, the second triangle pops right out from that given information. We only got one law of sines we have to do for this one. So 16 over sine 60 equals C2 over sine of 17. So C2 is equal to 16 sine 17 over sine 60, which gives me this side to be about 5.4. So these are our two different triangles that can be formed based off of this information that's given. This is probably the hardest style problem because of figuring out that you have two triangles and then where to start on the second triangle. The first triangle should be straightforward with everything that we normally do. So the area of an oblique triangle. So the area of a triangle equals 1/2 the product of the lengths of two sides times the sine of their included angle. So in this case right here, area is equal to 1/2 B side B times side C times the sine of angle A, or 1/2 side A times side B times the sine of angle C, or 1/2 times side A times side C times the sine of angle B. It all just depends on what you're given here on which one we need to use. It's just like the law of sines. We can equate them in any way. We could prove this using this drop down of H and using the Pythagorean identity, but I'm not too worried about us being able to prove stuff like that. So we're told, find the area of the triangle, round to the nearest whole number. So draw it out. Don't be afraid to draw this out. So angle B is 36. So if we did A, B, and C, so side C is 6, side A is 3. So by our definition, it says it's going to be 1/2 side A times side B times, or side C times the sine of the angle 36 in between them. So 1/2 times 3 times 6 gives me 9 times sine 36, which is 5.29. It says round to the nearest whole number. So the area of this triangle is 5. And there's a lot more complicated ways that we could find area that we don't have to really worry about, but we do need to think about these basic cases right here. All right. So the Leaning Tower of Pisa in Italy leans at an angle of about 84.7 degrees. The figure shows that 171 feet from the base of the tower, the angle of elevation to the top is 50 degrees. Find the distance to the nearest 1/10 of a foot from the base to the top of the tower. So in other words, we're looking for B. So there's a few things that we have to check here. So the first thing is, could we just find B straight up? Yes. So B divided by the sine of 50 is equal to 171 divided by, so this angle C up here is 180 minus 50 minus 84.7 is equal to angle C. So 45.3 is equal to angle C. So therefore 171 over sine of 45.3. So B equals 171 sine 50 over sine of 45.3, which is equal to 184.3. So that's what we're saying right now is our thing. Now, our angle A, now, no matter which way we look at this, angle A is acute. It's 84.7. And side A is greater than side B. And we could find that out by actually doing the other calculation here. A over sine of 84.7 is equal to 171 over sine 45.3. So A equals 171 sine 84.7 over sine of 45.3, which is equal to 239.5. So A is greater than B. A is acute, one triangle. Therefore, the value that we found for B at 184.3 is our height to the nearest tenth of a foot from the base to the top of the tower. So, different things that we got to consider in each case. It's just different applications using the exact same formulas, just in different applications in different ways. The hardest part is trying to figure out whether or not we have no triangles, one triangle, two triangles, and then how to find each one of those based off of what we know. So in every case, we got to make sure we identify different things. Just understand that even though H equals B sine A in general, we could change this based off of what's given. This could be a sine angle B. Doesn't matter. I can change it in any way based off of what information I give you in the problem. It's just a matter of changing variables around. So just be aware of that whenever you're working your homework and everything. So that ends our lesson.